The Metis Tech Show.
Welcome to the Metis Tech Show, a show for HVAC professionals by HVAC professionals.
The Metis Tech Show.
Mitsubishi.
All right, dogs or cats?
I'm going with cats.
No, dogs.
No, cats.
Cats are losers.
I have dogs and cats. I have 3 cats
I've
and
had both
3
too.
dogs.
I've had both.
I had a cat named Toolbox.
Toolbox.
That's where he
Really?
slept in the toolbox.
He did?
Well, what are you going to name the cat? I don't know. He sleeps in the toolbox. Good name. Thule for short.
I named mine Rambo. It was really a big cat.
When was the last time a cat was happy to see you when you came home, when you didn't go for the can opener?
When it's hungry.
Yes.
Dogs are happy to
only
see you no
time.
matter what. You leave your house for 10 minutes, you come back, the dog's like, oh my God, I thought I'd never see you again.
Yeah, I mean, but 2 completely different personalities, right?
Yes.
You have the
Oh,
cat
absolutely.
that is just independent.
The
doesn't
cat
really
is
care.
all about itself.
The dog is all about you, and
Yes.
the cat, you're just the cat's people.
I had dogs. I had a dog named Freon.
Freon.
American Eskimo. Yeah.
Really?
Freon.
I've always had labs.
I've had all kinds of dogs. I had a beagle. Well, I'm Portuguese, so I have to have a beagle.
What is up
That's
with that?
required.
Everyone
No,
I know.
Beagles are nice. They run away, but they always come back.
I was in a park about 3 weeks ago.
Did you say you were in a pack or a park?
He said pack.
Oh, pack. He did say pack.
That's park for anybody outside of New England.
Good Lord.
Park.
Welcome to the Metis Tech Show. My name is Steve Pimentel. We got Roland Wager out of the Orlando Training Center. Juan Cardona out of the Ohio Training Center. We have
Arriba.
Paul Shaves from the Boston Training Center. Welcome, everybody.
All right. Nice
What
to
are we
be here
talking
again.
about today?
LEVs?
LEVs.
Sure, that sounds good.
LEVs, yeah.
LEV operation and troubleshooting. So some of you may be asking, what is an LEV? It's a linear expansion valve.
Did you-
Right? It stands for linear expansion valve. Don't overthink it. It's just a metering device.
Absolutely.
If you're in the HVAC trade and refrigeration, you know what an expansion valve is, a TEV or a TXV. It's just an electronic expansion
Electronic
valve.
That's all it
valve.
is. It's
That's
a
all it
metering
is.
device.
It opens, it closes.
Right. So we have 2 types of expansion valves in our Mitsubishi electric systems, right? So
Right.
we have a magnetic style coil, magnetically driven valve, and then we also have a gear driven type LEV. And we'll talk about both. And there are differences between residential equipment and commercial equipment. So let's start with residential LEVs, Juan.
All right. So the residential LEV normally will have a magnetic coil that comes with a magnetic coil type that snaps on the top of the body.
Right. And it snaps right onto that tubing.
To the
There's a little
tubing,
clip on
correct.
there, right?
Correct. And that's the key. You got to make sure that it snaps on, because I've seen them not snapped in and they will work themselves loose on the top of that valve body, and then they can't really measure properly.
Yeah, and the travel distance is going to be off
Yes.
too. So that's going to throw some things off.
Yeah, and Juan, where is the LEV typically located on a residential unit? Because it's different than what you might think,
You're absolutely correct. Yeah, it is located on the outdoor unit.
which is why we need to insulate both lines.
Yes.
Absolutely. Good point.
Yeah,
Good
no
point.
sight glass.
No sight glasses, no
You
filter
just-
dryers. That was
Right.
a different episode. But yeah.
Right.
3 years ago, I had a gentleman in Virginia that installed a one-to-one MUZ system, and he was an older refrigeration type individual, and he would install a sight glass on every piece of equipment he installed. So he calls me up. And he said, "Juan, I've been charging. It's a 9,000 BTU unit, so you know where I'm going with this."
Yeah.
I do.
So I said, "I've been charging this unit. I've got 10 pounds of refrigerant in this system, and I cannot remove the bubbles."
Yeah, because it's right after the metering.
Yeah.
device.
this thing
Downstream
called
from the
flash
LEV.
gas. Yeah,
And then
yeah.
I told him, "Well, and that's how I got him to see it." I said, "Where's the LEV located?" And he thought a little bit, and then he said, "On the outdoor unit."
Yeah.
Interesting.
Yeah,
Yeah,
no.
that old beer can cold. It's still a lot of people your age, Juan. It's hard to get that out of
That
their
is.
heads.
It is. It sure is.
Now, there is a slight difference on the smart multi branch box type residential unit. They're located in the branch
The
control,
branch
in
box.
the branch box.
Correct.
Right. So the valve body consists of a needle and a seat. So
Right.
it's very similar to an automatic expansion valve or TXV or TEV, where there's just a needle and a seat in there.
Yeah. And the way that I see it operating also, Steve, is like a motor. The coil provides the magnetic field that drives that valve up and down, opening and closing it.
Absolutely. Yeah. And so that magnetic head consists of 4 coils. So 4 coils inside embedded into that magnetic head, and each coil is pulsed at different intervals to open or close that valve.
And
We're
it's
going to talk
pulse.
about voltages and stuff.
I'm sorry, Steve. I stepped on it. And it just pulsed with a DC voltage, right?
That's right. Just straight DC.
12 to 13 volts DC.
Yep.
So what controls that LEV? What opens and closes that LEV on a residential system?
You have multiple things: demand, temperature, superheat,
Superheat targets, yeah.
subcooling. It all depends on the model.
So we're not just looking like a TXV, the old TXV.
No,
we're not
no,
just looking
no,
at
no.
suction line temperature. We're looking at more than just that.
Yes.
And you notice our equipment runs a pretty low superheat on the coolant side.
Yes, it's 0 to 5 degrees. Imagine a conventional system operating at a 0 degree superheat.
Oh, everybody be screaming flood back.
Yeah.
Yeah, so it's a little different. We're on the most basic of systems. We're looking at just a temperature thermistor to drive that coil opener or that valve body open or closed. And it could be a little more sophisticated, like the smart multi-unit, where it's looking at a lot more targets like subcooling to
Correct.
open and close those valves.
Yeah, and that's one thing that we need to mention also, and we will as we get along on the residential and commercial types of valves. Not all valves meter. That's one thing we need to understand there.
Right, a good point.
Some LEVs are used for refrigerant flow control. Some are used to maintain a specified subcooling at the outdoor unit.
Right,
So
right.
there's different uses for LEVs. There's one that will meter to the indoor coil, but the system may have more than one LEV.
Juan, a question I used to get a lot when I was in the classroom from students is, how do you open the LEVs when we're going to evacuate the system? Do we have to open the LEVs? What's their position when they're not energized?
When they're not energized, typically they come open from the factory. Now, when you energize them, the first thing that they do is they go completely close. We call that homing because they find that reference point. They always go fully closed to find that reference point. Then they go back to its initial position, but they don't fully close.
So, and even when they're fully closed electronically, they're not fully closed
No.
mechanically.
They're typically, depending on the size of the valve, depending on how many steps to fully open they are, it could be for instance, on a 480 valve, step valve, they may close down to about 8-10 steps, but they're not down to 0.
Not
So,
100% closed.
Yeah.
Yeah.
So a technician should not be concerned with opening or closing or adjusting any valves before evacuation.
Absolutely.
Absolutely. Yep.
Yeah, so this typically on a residential system, we're looking at a step range of 0 to 500 steps. When we talk a little bit later in the commercial LEVs,
It's a lot
larger
wider.
range.
Yeah, those numbers change.
Valve
Yep.
bodies could be larger. Now, how can we see the LEV position?
I'm glad you said that because you can't. That's an assumed value. The only way you can see it is through maintenance tool.
Yeah.
Right.
Yeah.
Right.
I mean, you don't know how many pulses that command has been given to that valve. The only way to do it is through maintenance tool.
Now, it's an assumed step position.
Yes.
You got to remember this. So that the LEV has no way of knowing if it's actually closed or open.
Or
It's trying to do its job, right? Whenever we reset power, that LEV is going to reset itself.
Yep.
But we could have a stuck valve body and there's no way of knowing, the valve has no way of knowing its own position, right?
Right.
So we'll talk a little bit about diagnosing some of these things.
Yeah, one giveaway that I love about the LEV is that tells me when that valve is actually active is the ticking sound that they make.
That's right. It doesn't make a chirping sound.
Yeah.
As in motion.
Right.
Yep. Yep.
And those, glad you brought that up, that those ticking sounds you can hear those in the branch box.
Oh, yeah.
So isn't location of the branch box really important? Do you want to
Absolutely.
install that right above someone's master
Yes.
bedroom?
Yeah.
probably not a good idea. I mean, it's not extremely loud, but it sounds,
Yeah,
you know, like a pen clicking almost. And you got 5 valves in that box, and
Right.
you get pretty loud.
Yeah, you don't want to create pain in the homeowner's
Right,
mind.
Yeah. In the middle of the night when they're sound asleep, that pen clicking is going to
Yeah.
sound
It
a
could
lot
be-
louder than it would
Yeah.
if it
Right.
was during the day.
And most of the time, people put that branch box in a location for better distribution to the different heads anyway. So
But that ticking is not a problem. That ticking is normal operation. That's one thing that the homeowner needs to understand. But more so, like you mentioned, Steve, the contractor needs to be aware of that in where to locate that branch box.
yeah, and that all comes down to educating the customer as well.
Yes.
Yeah, so we have a resting position or minimum position for that LEV valve we just talked about. So refrigerant is always leaking by, or oil, so we can get that oil or refrigerant back to the compressor.
Where it belongs.
Especially with multi-zone systems. So let's talk about multi-zone systems. You may have noticed before where you have maybe 4 indoor units on a multi-zone system, 3 are running, and 1 system is not. But you feel the coil is cold, or the refrigerant going through it. And
you might hear
what is
that.
this? Well, that's the LEV doing in the branch controller or in the ported unit, letting that refrigerant leak by or pump itself down, so we're not trapping refrigerant in the indoor unit.
Back to
we're
what
getting
I said
back.
earlier, refrigerant management.
Yeah.
Because, you know, if you've got, and that's a great example, Steve, you've got a 4-ton unit outside, and then you've got 4 1-ton units inside, but only 3 of them are running. What are we going to do with the remainder of the refrigerant? We got to use it. We got to send it somewhere.
Oh, if one of them is running, you send
Right.
3 different locations as
Exactly.
far as refrigerant management. Yeah.
So on the residential side, not all, and commercial side, not all LEVs are metering refrigerant for the evaporator.
Correct.
We're using LEVs in the subcooling coil. So at Mitsubishi, we love to subcool, all the way down the line.
Absolutely.
Right? So we may be doing that in a tube-and-tube heat exchanger. There's an LEV for that. We have LEVs that meter refrigerant for flash injection.
Yes,
with
the hyperheat
hyperheat.
units.
Absolutely.
Right. We have LEVs that will meter refrigerant through a condenser coil in heat pump and heating mode. Right.
Yes.
So you may have up to 3 or 4 LEVs in a given system. Again, depends on model. The most basic Mitsubishi Electric FH style model is going to have one basic metering device, whether it's in heating or cooling.
And
We're
in that
an
model,
MXZ
it meters refrigerant both ways.
both ways. Yeah. Where an MXZ branch box may have multiple.
Multiple
You know,
LEDs.
you're going to have up to 5 in the branch branch controller or branch box, and maybe 3 in the outdoor unit. Right.
That's right.
So we've talked about primarily the residential LEVs, and they're in the outdoor unit or the branch box.
Or the-
if
or the
you got
branch
the
box,
multi-zone, the smart branch box style. What about commercial equipment?
Before we get to the commercial side, one thing we need to mention also that we have a tool that will allow you to manually open and close that valve. And the part number for that tool is T as in Tango, 2, number 2, W, E, A, 5651. Paul, would you repeat that?
Yeah, Paul,
Tango,
you were in the military, so you'd be able to do this.
Yes.
Tango 2 Whiskey Echo Alpha 5651.
Wow.
For you veterans.
That's impressive.
It is.
It is.
I love doing the tango, though.
You do. Yes.
I can tango.
I know.
I
you
like
can.
having a nice glass
I
of
think I got it
Tango.
on video somewhere. That is the LEV magnet again.
Yes.
So a great tool. You have to manually spin the magnet. There's a little marking position on it. Says open and closed.
Arrows. Yep, directional arrows.
Steve, give me a scenario when I, as a technician in the field, would need to use that magnet.
So I've just diagnosed my LEV magnet, and I found out that the coil is defective. So what can I do? Well, now I want to find out if maybe that LEV body is stuck closed. Maybe I have a good LEV magnet. I'm just going to put that magnet, put that tool on the valve body and see where the valve failed. Did it fail closed? Did it fail open and I'm flooding the compressor? Or did it fail closed and I'm pumping the system down? And it gives the technician an idea of where he is on that valve, for where it failed. Now, can I get the system running for the customer? you got to be really careful with that.
Yes.
You got to dial in the superheat, and then even then, be really careful about leaving a system running with the LEV wide open. We don't want to flood the compressor and damage.
Yeah,
cause
and
damage
that
to the
doesn't
system.
happen in 5 minutes. You're going to have to wait and let
You
it
gotta be
run.
patient.
Right. So basically, if I have an LEV head that's failed electronically, that magnet is going to let me know whether it's also failed mechanically. Or maybe I have the proper voltage going to it, and electrically it's fine. If I open it up, then we know mechanically it's fine as well.
Right.
Yeah. So let's talk about that LEV body itself. Keep in mind that there are strainers protecting that LEV. On most systems, there is a strainer on the inlet side of the LEV and the outlet side of that
Yeah, both
LEV.
sides.
Because it's such a small part, and that needle seat that's in that valve could get clogged with anything from a sealant or something you introduce into that system that does not belong in there.
And let me just say something about that magnet. You also have to ride that on the top of the LEV stem. You know, sometimes some of the stems are a little bit longer, and if you let that magnet drop down to the bottom, it's really not catching the magnet. So how do you know you're catching the magnet? As you close that, when that finally gets closed, it starts to bite. You can actually feel it, a clicking. And then vice versa, when you open it all the way, you can actually feel that, biting that magnet because
there's like a
it's
bumping.
seated. It's either bottom or top seated.
And the LEV magnet has arrows marking which way is open and which way is
Yeah,
closed.
we've done it in class. We've actually adjusted them in class and took one of the favorite things you like to do, temperature drop across that coil.
Exactly.
And we've changed the temperature drop across that coil by just showing how that magnet works.
Right.
All right. So that magnet again, if you're interested, talk to your distributor. The part number is Tango 2 Whiskey Echo Alpha 5651.
Awesome. Let's jump into commercial LEVs. Now we we have two types of LEVs. The actual not so much the valve bodies change. Well, they do a little bit, but we have a gear driven and a magnetic coil, just like the magnetic coil in the residential.
Right, and
systems.
we may have magnetic type LEVs on the outdoor units, while we have the gear driven valves on the indoor units.
Right. So let's talk about that. Commercial now, we're more of a traditional HVAC system or refrigeration system where the TXV, the expansion valve, our linear expansion valves are in the indoor units. It's more like a typical HVAC system. We're not metering at the outdoor unit, but we will see LEVs in the outdoor unit, the branch controller, and all the indoor units.
That's correct. And the one in the indoor units is used two different ways. One for superheating in cooling, and subcooling in heating.
Yep.
So it's going to measure the not necessarily measuring in the heating mode, but it's going to manage that refrigerant coming out of that coil.
Just regulate the flow.
Yes, there you go. So yeah, we've got LEVs located in the commercial side, both at the outdoor unit, indoor unit, and as well as the branch controller. Some of the valve bodies themselves are larger, so it would require a different type of magnet to be applied on that valve body.
So that magnet part number that we gave out earlier is for residential equipment only, correct?
Yes.
Well, no, not necessarily, because new end generation equipment, all the valve bodies mimic the residential valve
Oh,
bodies.
do they?
Beautiful.
Perfect.
So
Perfect.
the LEV magnets now fit on those, but not so much on the older generation. You're going to find some larger valves, and you got to kind of get creative.
Right.
All right. So we've seen technicians take an old LEV coil and put a 9-volt battery across the common and one of the coil wires on that coil, and now turned it into their own tool. Because now what you're doing by energizing one coil, you can manually turn that old LEV coil by hand and open and close a larger valve where that smaller Mitsubishi LEV magnet tool does not fit.
I've seen a couple of those contraptions.
Yeah, you just created one.
yeah.
So just one wire at a time in the right sequence, and I can open and close.
And also, just
you
to
go.
just to note that if you're a commercial piece of equipment, City Multi, you're going to have a maintenance tool on it. At that point, you can see what step that LEV is at as well.
Yeah, one thing I like is the consistency across the brand, the models, because all LEVs, whether it's on the residential side or the commercial side, they're powered by 12 to 13 volts DC. There's no difference there.
Right.
Roland, can I drive? You mentioned maintenance tool. I can see the LEV position. Can I drive that LEV?
You
open or
absolutely
close using
sure
maintenance
can.
tool?
You
Sure.
can drive operation.
That's
You
right.
can force command that LEV.
So now we talked about residential step positions being anywhere from 0 to 500. We will see that on commercial units as well, but we have a wide range of steps now. We have valves that open to 2,000 steps, 3,000 steps, and on our larger chassis, our larger condensing units, we're looking at 0 to 6,000, up to 6,000 steps on some of our valves. All right, so LEV, again, we said LEV position can be seen using maintenance tool, driven with maintenance tool open or closed.
Right.
Okay. What about gear-driven type valves? Those can be found on indoor units. They can be found on branch controllers.
Yep.
Right, and they're just they're like an aluminum colored valve. Right, they screw onto the valve body with a wrench, so it's actually a nut that screws onto the valve body. You don't have to remove the refrigerant to remove the valve,
That's
which
the
is
beauty of it.
Thank God, right?
Right, and then one more thing, Steve, on the gear-driven, if you replace one of those coils, you need to read the instructions. because the
Absolutely. I was going to go there.
Will tell you that you have got to drive that coil. There's a pin in that coil body that will press on the actual pin in the valve, and if you don't drive it completely open or up, depending on how you're looking at it, if you try to screw that head to that valve body, you will damage the body, and you have to replace the whole thing.
In these instructions that you mentioned, Juan, where can I get them?
They come in MyLink Drive. Service
Drive
manual.
on the service manual for the particular unit you're working
Absolutely. Specific unit.
That's right.
Absolutely.
Excellent. So now let's talk about what can go wrong with LEV valves. And now I need to diagnose an LEV.
What are you talking about? LEVs and Mitsubishi units don't break.
on. That's it. Show's over.
Right? We wish.
It was a small
People
pause.
break Mitsubishi.
So now I need to diagnose that LEV coil. Let's talk about coils. We need to diagnose that LEV coil.
Mm-hmm.
I'm going to check the resistance across all 4 coils in the magnetic head. Okay, and I'm going to look where?
In the service
Drive.
MyLinkDrive.com.
MyLinkDrive.com service manual
Yes.
specific to that unit. Check, find my little chart there where the resistance ranges are listed, and then diagnose that coil by putting my multimeter in ohms and ohming out each coil in that magnetic head.
One more thing that we need to know also when you're ohming the resistance of those coils is that let me ask you guys, does temperature change resistance?
Yeah, absolutely.
yeah.
Yes.
Absolutely.
So you don't want to be checking this outside when it's 0 degrees outside. You want to bring it inside, let it reach, like the indoor temperature between 60 and 70, because there is a range that may be given on that chart for you to look for a range of resistance values.
Yeah, I think I'm looking on that right now, and they give you plus or minus a certain amount of ohms. It's minimal, but once again, you're going to have a common wire that's probably going to be involved in all the readings. So, just take that ohm reading.
All right. Now, something to look at with gear-driven LEVs, they could test just fine with resistance, but what's wrong with our gears?
You get something physical.
They're stripped.
Yep.
The gears can be stripped, but the valve checks out fine. So be aware of that. You still have a defective valve, even though it's checking out on your multimeter correctly.
And what is the easiest way of checking if the valve is open or closed?
Well, you can do temperature drop across that,
Exactly.
because if you got liquid there and you got metering effect happen, Charles' law, you're going to have temperature drop, pressure drop, temperature's going to follow.
Yeah, you may see some frost out on the outlet side of that valve if it's in a metering position.
If it's metering, like Roland said, there is a temperature difference.
And if I got my hearing aids in,
You can almost hear that tick, tick, tick.
and you can hear a little bit of refrigerant flow as well.
Yes.
Now, on larger systems like commercial systems, you'll hear an LEV that's wide open and bypassing refrigerant. It's pretty loud.
Yeah.
All right. So
Running
That's a
fluid
dead
sounds like running
giveaway.
fluid. I would say water, but I don't like to use that. Running fluid.
but bypassing hot gas directly by the condenser coils, you'll hear that.
Right.
Right.
The one thing that we also need to be aware with these LEVs is that the contact between the coil and the valve body is open to the ambient air. So moisture is going to get in there. There's going to be corrosion on the body as well as the coil. So we recommend using like steel wool, something very light
Abrasive.
to clean.
Yep,
Right.
very
Something
light
very
abrasive.
light abrasive to clean the body and the coil, and then follow up with a dielectric grease.
And that's a common thing by the ocean.
Yes.
In Florida has two shorelines, the east side, the west side. Everything's by the ocean. So yeah, that's a very common for those things to be all.
And it can get to the
corroded.
point where you need to hammer that LEV coil off of the body, and God forbid,
yes.
that's what you have to
I could
deal
see
with.
that happening in Florida.
But be very careful not to damage anything else at that point.
Yeah,
But
you scare me when you said hammer.
I've actually seen some that have just fallen off.
yes.
They just kind of worked their way out. They weren't snapped
eats it
in
up.
good, and they just kind of worked their way out, and it's just hanging there.
Yep.
But what about just a bad control board?
It happens.
Absolutely.
No signal being sent to the LEV. Can thermistors throw off what an LEV's job?
Absolutely.
Absolutely.
They could be measuring the temperature value.
Yeah, so I got a thermistor that's out of range. It should be reading 55 degrees, and it's reading 140.
Yes.
That's going to dramatically change how LEVs operate.
And I'm sure we'll have an episode on properly testing some of those thermistors.
Yeah, because your thermistor could get debris on it, so now it's not really reading just the temperature of the pipe; it's reading the temperature of the debris. Absolutely, it should be inspected.
Right.
And part of the PM, preventive maintenance.
Exactly. There you go.
So just to recap, we have two styles of LEVs, magnetically driven and gear-driven LEVs. When we look at the residential units, they're on the outdoor unit or the branch controller. Okay. And when we look at the commercial units, we have many more places that we can find LEVs. The outdoor unit, the branch controllers, the indoor units, and they all have different jobs.
Yes.
Not just metering refrigerant into the evaporator coil, but also managing flow, segmenting coils. And we're going to have, again, like Juan said, we're going to have further episodes
Yes.
where we're going to get more in depth.
And also, too, in mylinkdrive.com, if you go through the literature, you can see all the information that you need to know about what that valve is supposed to do, how it does it.
Yes.
Like you just said, segmented. And all that information is right in there.
Do you guys cover a lot of these topics in your training classes?
Oh, yeah.
Yeah, we sure do.
All right. So where do I go if I want to take one of your training classes?
Very good. I'm going
Why
to tell
don't you tell us, sir?
I'll tell you. You can go to MitsubishiComfort.com. You'll click on 4 Professionals and 4 Pros, and you can find our training centers and the courses we offer.
You got it.
Excellent.
Thank you. Good show.
And if you go to one of Roland or Juan's classes, let them know you heard this podcast. I'm sure they'll be happy
That
to
would
hear
make us feel really good.
Well, guys, thanks for sneaking by again.
Thank you, everyone, for listening. And our target is for us to improve you as a technician.
Yeah, absolutely. We'll see you on the next episode.
Yeah, never stop
right.
learning, guys.
Hasta la vista.
I'll be back.
We'll see you later.
Tools.
Adios.